Good morning to everyone. I am Dr. Sathya, working as an assistant professor in Department of Chemistry, SNS College of Engineering. Today we are going to discuss about IR spectroscopy. So in that molecule, we know about the structure of the atoms. So what are the molecules present in the compound? So what type of the structure present in the molecules? So we know about that structure of atom. So the lot of instrumental methods to analysis the structure of the molecules. So not only in structure, number of bonds and shape. So lot of things we have to analyze from that spectroscopy. In four major spectroscopy in instrumental method analysis: nuclear magnetic resonance, infrared spectroscopy, mass spectroscopy, and ultraviolet spectroscopy. In infrared spectroscopy, is the deals with the infrared region of electromagnetic spectrum, that is the light having a longer wavelength and a lower frequency than visible light. Infrared spectroscopy generally refers to analysis of interaction of molecule with infrared light. So in that, spectroscopy concept can generally be analyzed in three ways: measuring reflection, emission, absorption. So the major use of IR spectroscopy to determine the functional group of molecules relevant to the both organic and inorganic chemistry. So before seeing the structure determination, how do we know what atoms are connected together, how the atoms are linked through the bonds? So what type of the bonds are present? So which type of the bond, I mean single or double and triple bond? What functional group are exist in molecules? If we have the specific stereoisomer, what are the structural isomers are present in that molecules? So the lot of things we have to discuss in structure determination. So in this structure determination, the IR spectroscopy is very useful technique to determine the functional group of the molecules. So already we discussed about the spectroscopy in the last series, but it's a study of interaction between matter and electromagnetic radiation. So it's concerned with the study of absorption of infrared radiation, which causes the vibrational transition bonds of a molecule. So it's also called it the vibrational spectroscopy because the molecules are always in vibrating mode. So IR spectroscopy mainly used to identify the functional group, but also gives the information like number of bond, specific stereoisomers, atomic rearrangement in the molecule. So IR radiation is largely thermal energy. It induces the stronger molecule vibration in covalent bonds, which can be viewed as the spring holding together two masses or atoms. The specific bonds respond to the specific frequency. So when the chemical sample is exposed to the action of IR light, it can absorb some frequency and transmit of the rest. So some of the light can also be reflected back to the source. So in the molecular vibration, we have two types of the vibration. One the stitching vibration and other one is the bending vibration. In stitching vibration involves the continuous change in the interatomic distance along the axis of bond between the two atoms. In the symmetric stitching and asymmetric stitching. In symmetric stitching means the bond length increases and decreases symmetrically. In asymmetric stitching, the length of one bond is increased and the other bond will be the decrease. So in the symmetric stitching, the same bond will be moving the same direction. In asymmetric stitching, the one bond will be increases and the other bond will be decreases at the same time without changing the bond angle. So in bending vibration involves the change in between the angle between the two atoms. So the four types of the bending vibration is possible: scissoring, rocking, and wagging, and twisting. In scissoring, the movement of two atoms toward away from each other like a scissor. So bond angle decreases and increases with the time. So rocking, in which the bond angle is maintained but bond moves with the same plane, the changing angle between the two group of atoms. In wagging, in which both atoms moves one side of plane and changing the angle between the plane group out of the atoms. So the twisting, in which one bond is above the plane and the other one is the below the plane. So the changing the angle between the plane to the groups of atoms. Measurement of pH. Since the resistance of quite high, the specific electric remedy is employed to the measurement. So working the source of energy strikes the beam splitter that produces the two beams roughly the same intensity. So the one beam strikes the fixed mirror and returns to the beam splitter. The other beam goes to the moving the mirror. When these two beams meet up the again at the beam splitter, they recombine. So the recombined beam passes through the sample. So when the IR radiation interact with the sample molecules will absorb the specific applied quantized IR light. It will be matched to the internal vibration frequency of the molecule and the resonant frequency or the transmitted via the sample. Here the spectrum of IR spectrum is given in this picture. So we know the functional group present in that molecule. We have this type of the peaks. So thank you to all.